All right, in this video, I'm going to solve a little bit of a more difficult algebra equation that's going to involve fractions and also is going to involve solving a quadratic equation because those are both things that'll come up quite frequently. So there's the equation I want to solve. It looks pretty simple, but it actually gets a little bit hairy to solve. So let me just get started. First thing we want to do, we've got a fraction there that has variables in the numerator and in the denominator. So we will need to get rid of that fraction. The way you get rid of a fraction is by multiplying both sides of the equation by the denominator of the fraction. So in other words, what we want to do here is multiply both sides of the equation by x plus 2. So we'll have x plus 2 times 1 minus x over x plus 2 equals x plus 3. And crucially, x plus 2 goes away in the denominator, which was the whole point of this. But on the right-hand side of the equation now, we've got to add an x plus 2 there, or multiply by an x plus 2, as it were. So the left-hand side of the equation just becomes 1 minus x. The right-hand side of the equation, now to multiply those two guys together, we need to add together every possible combination of the two things in parentheses. You probably learned the FOIL method to do this, is the way most people do it. So we're going to have, the way we think about this is we do x times x, and then we do x times 2, and then we do 3 times x, and then we do 3 times 2. So that's going to give us 4 different quantities. So x times x is x squared. We've got x times 2 is 2x. Then we've got 3 times x is 3x. Then we've got 3 times 2 is 6. So there's my cleaned up equation that has no fractions. Let me simplify a little bit. First, let's get these two guys combined with each other. 3 plus 2 is 5. Okay. Now, next up, we have here a quadratic equation, meaning that we have an x squared in there. So this is going to be, we can't solve it just with the trivial, just kind of solve for x method. The foolproof way to solve an equation like this is to use quadratic formula. So if you don't remember that, the way you apply quadratic formula is first you set up the equation so that you just have a 0 on one side of the equation. So I'm going to solve it so that there's a 0 on the left-hand side like this. That means I have to subtract 1 from both sides, and I have to add x to both sides. So x squared is unaffected by this. The x, I have plus 5x, and I'm going to have plus 1x from the term that I brought over from the other side is going to give me 6. And then I have plus 6, and I'm going to have minus 1 from the term on the other side. So I'll end up with this. Now, once you've got the equation written in that manner, the way quadratic formula is set up is, the way most people state it is, you want your equation to look like the form ax squared plus bx plus c, which you can see I did already. So a represents the coefficient that's in front of the x squared term, which in our case is just 1 because there's nothing there. B is the coefficient in front of the x term, which is 6 in my case. And C is the term, why did I put it minus 5? It should be plus 5, of course, because that was 6 minus 1 is 5. So C is going to be 5. These terms could turn out to be negative. They did not in this case, but A, B, and C could be negative in some problems. Once you've identified your A, your B, and your C, the next thing to do is use quadratic formula. And quadratic formula says that the solutions to this equation, there are 2 of them in a quadratic equation, and they both have the form x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we just plug in the a, b, and c that we identified into this formula, and it should give us the answer. So we've got negative b, so that means negative 6. The plus or minus sign, I'll explain how to handle that later. Then we've got the square root of b squared, 6 squared, which is 36. Then we've got minus 4 times a, which is 1, times c, which is 5. And then the denominator, 2 times a, is just 2 in this case. Okay. When you have two things added in the numerator of a fraction like that, you are allowed to break it up into two fractions, which I'm going to do. So I'm going to have the first term is negative 6 divided by 2 is negative 3. That comes from 6 over 2. And then plus or minus, this one's going to take a little bit more work. So inside the square root, I've got 36 minus 4 times 5 is 20. So 36 minus 20 is 16. So square root is 16 divided by 2. And square root of 16 is 4. So that's going to give me minus 3 plus or minus 4 over 2 is 2. And that happened to work out really nicely. By the way, if you are going through this process and you end up getting a negative number inside of your square root, then something is wrong. You've made a mistake. Or the problem is not solvable at all. The problem has no solution. So you should always get, notice that I got positive 16 in the square root. You should always end up with a positive number inside the square root if it's a normal solvable problem. Okay, now how do you handle that plus or minus sign? The plus or minus sign literally just means it could be a plus sign or it could be a negative sign. So in other words, this actually has two solutions. The first one is x equals negative 3 plus 2, which would be negative 1. And the other one would be negative 3 minus 2, which would be negative 5. So those are both solutions to this question. Oftentimes in the world of physics, one of the two solutions will be the one that the question is actually asking about, or the one that actually makes sense as the answer, and you might just discard the other one. But technically they're both answers to the algebra question that you set up. And you can actually verify that if you want to up in the original equation. Like we've got negative 1, so that would be 1 minus a negative 1 would be 2, and then we'd have negative 1. Well, let me just do it really quickly over here. So if I plug this back into the original equation just to check my answer, so I'm going to have 1 plus 1 over x plus 2, so that's negative 1 plus 2 equals x plus 3, so that's negative 1 plus 3. So that gives me 1 divided by 1 is 1. Sorry, 1 plus 1 is 2, divided by 1 equals 3 minus 1 is also 2. So this gives me 2 equals 2. So that works. What about the other solution? We had negative 5. So I'm going to have here, I'll have 1 plus 5 over negative 5 plus 7 equals negative 5 plus 3. So that's going to be 6 divided by 2 equals negative 5 plus 3 is negative 2. Wait, that didn't work. Did I make a mistake? 3, 4 divided by 2 is 2. Negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. 1 minus a negative 5 is 6. Negative 5. Oh, why did I write negative 5 plus 7? Negative 5 plus 2 is negative 3. And so that gives me negative 2 on the left and negative 2 on the right. Yes. So those both work out in the end. So they're both true. So those are the two solutions. So the key points here, dealing with fractions, the easiest way is just to get rid of the fraction by multiplying both sides by the denominator if you can. Sometimes it's a little bit more complicated than that, but you just have to bear with it and try to simplify. And then if you have a quadratic equation, you normally just use quadratic formula for that.